Networks are very like icebergs. Let me show you what I mean. In this network, we'll count the things that in media we generally count, which is the audience or the people. And in this network we have 1, 2, 3, 4, 5, 6, 7. We have 7 nodes or 7 people. And that's above the waterline. That's normally what we can count. Remember, we have lots of information called drop-down data on each of the nodes, but that isn't important information when it comes to understanding the relationships that people have with each other and how influence is propagated in a network. There are other things that we can count here though. Let's count the edges. We have 1, 2, 3, 4, 5, 6, 7 edges. 7 things that we normally wouldn't see. But already, we've doubled the bit rate of information pertaining to this network. We had 7 bits of information relating to the nodes above the line, and now we've found 7 bits of information relating to the number of edges below the line. But there's more information that we can add to this picture, particularly below the waterline and these edges. Let's add something that I call directionality. This person connects to that person, and so does this person. There's a bidirectional link, and all I'm going to do is just add in all of the connections that indicate in which direction a connection is created. And we can count that because we can count the arrows. In fact, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 arrows. That's another 9 bits of information below the waterline. But it can get even more interesting. This looks like an interesting individual. Let's count the number of connections. 1, 2, 3, 4, 5, 6. There are 6 edges for that person. This person has 2. This person has 2. This person only has 1. As you can see, I could go on, but it would be boring, but the amount of information below the waterline is really beginning to proliferate. But wait, there's even more. When we look at this person again, we can see they have 6 edges altogether, 1, 2, 3, 4, 5 of which are incoming, and only 1 of which is outgoing. I might write in and out to make it easy to remember. This person has 1 incoming and 1 outgoing. This person has 1 incoming and 1 outgoing, and again there are more bits of information beginning to add up amongst the edges. Now what's very, very interesting about networks is that all of this information together in the edges is together known as the topology, or collectively known as the topology, and it's the topology of networks that complex systems science studies. And this is really a lost continent of information and data. Because in large systems, what we find is that for systems of 1,000 nodes or more, 96% of all the data in a network can actually be found not in the nodes, but in the edges, in the topology of the network, which means there's a huge iceberg of data below the waterline, which until very recently we didn't really know was there.